This is the second video to section 3.5. In this video, we're going to see what happens when we multiply our function by 2 and 1/2. Let's start again looking at our graph of x squared. We want to multiply our function by 2. By doing this, we'll have 2 times x squared. So our new function is going to be 2x squared. Let's go back to our key points again, -1, 0, and 1, and let's plug those into our function. And when we do, we'll get these 3 key points. When we plot those points, we'll be able to draw our parabola through, and we'll get something that looks like this. Compare these two graphs. This graph right here looks skinnier than the original one. Now let's see what happens if we multiply x squared by 1/2 instead of 2. Again, let's take a look at what our function would be, 1/2 times x squared, and let's plug our key points into 1/2 x squared. We'll get these 3 points, and just to help myself, I'm going to plot another point as well. Here are the points, and let's go ahead and draw a parabola through those. Our parabola will look like this. When we compare this parabola to that of x squared, notice this parabola became a little bit wider. So let's remember, when we multiplied by a constant greater than 1, our parabola became a little bit skinnier. But when we multiplied by a constant less than 1, in this case 1/2, our parabola became a little bit wider. Notice the same thing is happening to our y values. Our original y value for -1 was 1. But when we multiplied it by 2, it became 2. 0 times 2 became 0. 1 times 2 became 2. The same is true for plugging in our points for 1/2 times f of x. Moving on to the next graphs, notice now we're multiplying by 2 again, but this time inside the parentheses. We're multiplying by 1/2 again, but this time inside the parentheses. Let's see what happens here when we plug in our key points. Our function will be 2x squared now, which comes out to be 4x squared. And if we plug in our key points to this function, we'll get these values, 1, 0, and 1. We'll go ahead and plot those points. And this is what it will look like when we plot those points. If needed, you can plot a few more points, but this is what it looks like when we multiply the inside of our parentheses by a constant. Let's move on to the second graph. We're going to multiply our function inside the parentheses by 1/2. And once again, let's go ahead and plug these 3 points into our function. And we'll get this. And let's plot our points. And here we go. And that's our parabola. Once again, please look at what each of these do to our original function. The one we just did looks like so. And compare that to the original graph of x squared. Taking a look at this box down here, let's see what we've just done to these graphs. When we multiplied the graph by a constant, like we did up here in the first 2 graphs, this was a vertical stretch or a vertical shrink. When our constant is greater than 1, like in the graph up here, it was 2, that was a vertical stretch. Whereas when it was less than 1, or in this case 1/2, it was a vertical shrink. These bottom two graphs here, when we multiplied the inside of our function within the parentheses by the constant, we had a horizontal stretch and a horizontal shrink. If our constant was greater than 1, as it was here, that's a horizontal shrink. But if our constant was less than 1, between 0 and 1, that was a horizontal stretch. That concludes the second video to section 3.5.